Yes, good evening and welcome back to Man's channel. Today we are going to look on how we can get the mean, the mode, and the standard deviation of ungrouped data using assumed mean. This is our data. We have a data with inclusive class interval. The first class interval, as it is indicated, is 70 to 80. The next one is 80 to 90, 90 to 100, as you move on up to 140 to 150. From there, we create the column of x, which is the average of 70, that is the lower class limit and the upper class limit. Then the next column is frequency of the data, that is f. The next column is d, which is x minus assumed mean. We take the value of x, then we subtract the assumed mean, which is 105, as it is indicated at the top here. Then the next one is of course d squared, whereby we square the values of d that we have just generated. Then the next column is f of d squared, that is frequency multiplied by the value of d square. Then the last column is of course fd, which is the product of frequency and deviation from the assumed mean. Then after that, we do the summation of the data for each column, and necessarily that one of the frequency, we see that the frequency is 230. The fd squared is 75,300, as it is indicated. Then summation of fd is 1250. Now here, summation of f is the total frequency, summation of f of d squared is here, and then this one is summation of f of d. Then from there we go to the question. We have been told to calculate a, the assumed mean. The mean, mean is summation of f of d all over summation of f, then plus a, where a is the assumed mean. So in my data, I have 1250 divided by 230 plus 105, which is the assumed mean, to get to 10.43. That is correct to 2 decimal places. From there, we have been asked to generate the mode. Now, this is the formula of the mode for the grouped data: L plus f1 minus f0 all over 2f1 minus f0 minus f2 multiplied by h, where h represents the class size or the class interval. Now, in this case, f1 is the frequency of the mode or class, and of course, when we want to determine the mode, we check the class with the highest frequency, which is 50. Then f0 is the frequency above the mode or class, which is 42. And then we have, of course, f2, which is the frequency of the succeeding class, that is the class below the mode class. Now, after there, we just substitute in the formula. We have L. L, of course, is the lower class boundary. We have 110. Because our data is inclusive, then it means that our 110 will be our L. So we have 110, we substitute 50 minus 42, then all over 2 multiplied by f1, which is 50, minus f0, which is 42, minus 45. Then from there we multiply by the class size. Now, as you move on with the calculation, we realize that the entire data gives us 116.15, which is our amount of the data. From there, we have been asked to calculate the standard deviation. The general formula of the standard deviation for the good data is summation of f of d squared over summation of f minus summation of f of d all over summation of f, then into bracket the square. So from our table you have 75,300 divided by 230, then minus into bracket 1250 all over 230, then you close the bracket and the square. From there you find the square root of the number that you are getting, and this gives us the standard deviation for the data being 17.26. That is corrected to 2 decimal places. That is the end of our lesson. Thank you for listening and continue following Man's Tutor. Goodbye.